Hi Pre-Calculus kids, today I want to give you some examples from the practice problems from section 11.4 on the double and half angle identities. The first one I'd like to do is number 3, the tangent of 140 over 2, and they want to know true or false, does it really equal a negative square root of 1 minus the cosine of 140 over 1 plus the cosine of 140. And what you're looking at are your formulas here, the identities. And so we're following this one, and I want to know the tangent of 140 over 2, so 140 goes in the x spots. I have a 1 minus cosine of 140, I have a 1 plus 1 cosine of 40, so that is true. Now the question is this negative or is it positive? And so I think about the half angle formula. Remember we talked about this in the intro video. I'm basing everything off of theta over 2. Well, if I've got 140 over 2, that means I've got 70 degrees. And if I'm thinking 70 degrees, I know I'm in quadrant 1. So I'm going to go back to the sheet that we talked about here, looking at my half angle formulas for tangent. In quadrant 1, your square root should be positive. And what they're showing you is a negative square root, and because of this negative, that makes this whole thing false. So the first few questions are they true or are they false? And it's based off of the identity. You just have to expand it out. All right, second one I want to do is number 5. And number 5 is a half angle formula again. And if I'm looking at the half angle for this guy, I know that because I've got the fraction there. And this one's also in pi language. So I know that 5 pi over 8 represents theta over 2. Now first off, before I go showing you the second step of this thing, what quadrant am I in? Am I going to be positive or am I going to be negative? Because remember, these are all those positive and negatives depending on what quadrant they're located. So if I'm 5 pi over 8, if I think about my coordinates, if I'm 5 pi over 8, I'm 5/8 of the way to pi. So I am a little bit more than a half. I'm over here in quadrant 2. So this one is going to be quadrant 2. Quadrant 2, and I am sine. So I go to my chart. I'm looking at my chart. If I am the sine of a half angle in quadrant 2, I am positive. And so I know I'm using the positive part of that square root. So I know that I'm going to put this as being a positive. Now the second thing I need to know is if you look at your formula has your theta or your x. It's kind of funny how they did this, right? This side they did put all in thetas and this side they did in x's, whatever. They're calling it the angle. So if I'm looking at the sine, I need to know what x is. And x, unfortunately, is not over 2. It's over an 8, right? I've got 5 pi over 8. So what I'm going to do is I'm going to take this expression right here. Theta over 2, x over 2, whatever you want to call it, is equal to 5 pi over 8. And here's what I want to know. I want to know what theta is. So the way that you get that, the easiest way to get that, now they'll show you a more difficult way, or they might have shown you a more difficult way on the flip math video, but the easiest way is just to cross multiply this. You know I'm a fan of that. So 8 theta equals 10 pi. And then I can figure out what theta is by dividing by 8. And so if I divide by 8, these cancel, I get theta. And this gives me 10 pi over 8, or 5 pi over 4. Now that's going to be important to me because that's the value that I have to use in my formula. And the formula says, we already decided it's a positive, square root of, for sine, it's 1 minus the cosine of x or theta over 2. Now my theta is 5 pi over 4. So you see how this value is the value you put in here. That's still in the square root. Now that should be where 5 pi over 8 was not a value on your chart. 5 pi over 4 surely is. So I'm going to go to 5 pi over 4. Let's see. 5 pi over 4 is this guy. And I want to know what the cosine is of that. Cosine is a negative square root of 2 over 2. And so that's what I'm going to fill in. So let me make this so you can see it. If I go to 5 pi over 4, go over to cosine, it's a negative square root of 2 over 2. And so that's what I've got here. So I've got negative square root of 2 over 2 is what's going in for this thing. So now I have a positive square root of 1 minus a negative square root of 2 over 2. And all of that is then over 2. So I replace the cosine of 5 pi over 4 with a negative square root of 2 over 2. And I showed you that there was a trick to these to make them a little simpler, and it was that trick to multiply by that denominator. So if I multiply by 2 over 2, which is a funny version of 1, so the math police will not come and take me away, I get a positive square root of 2 times 1 is 2. Negative negative is plus. Square root of 2 over 2 times 2 cancels the 2's on the bottom and the top. I get a square root of 2 here. 2 times 2 is 4. And I know the square root of 4 is 2. By the way, you don't want to cancel, you don't want to simplify these. It's not just the outside 4's that cancel because you've got a plus sign there. So final best answer is 2 plus the square root of 2. Let me make my square root sign a little smaller. All over 2. The square root of 4 is 2. And that's your final answer. Alright, on this side, the last one I want to do is number 8. Happens to also be a sign of x over 2. And for this one, they say for the directions 6 through 9, you're using this information. And you have to draw a reference triangle first. So we're going to look at drawing the reference triangle. So let me come up here and take the information. I'm in quadrant 2 with my reference triangle. And I know that because they told me right there. They say the sine is 3/5. Well, sine is, this is my angle, this is my theta, or x. Let me put an x in there since the problem's in x. X. Opposite is 3. Hypotenuse is 5. I need to figure out the missing side here. Do you remember what it's going to be? Do you know? Do you know? If not, Pythagorean theorem. This is, I'm sorry, it should be 5 squared, which is 25. 25 equals 9 plus x squared. That means 25 minus 9 is 16. The square root of 16 is 4. That's my value. It's 4. But what kind of 4 is it? It's negative, because look at where your x's would be. Okay, so once you have your triangle based off of all this, you drew your reference triangle, now you can answer this question. So, question number 1, we know it's going to be a square root, right? But the question is it positive or is it negative? Well, the reference triangle, x or theta, is in the second quadrant. And if you go back to this chart that I gave you, if your angle is in the second quadrant between 90 and 180, then it really, when I half the angle is in quadrant 1. And I'm looking at sine, and sine in quadrant 1 is positive. And so my answer is going to be the positive square root of that. So second quadrant for the actual angle, half them out, means that it really is between 45 and 90, and 45 to 90 is still in the first quadrant. And so you're using sine over 2 of x over 2, theta over 2 in the first quadrant, and that's a positive value. So we know it's going to be a positive square root. And then I'm going to fill it in. My formula says it's going to be 1 minus the cosine up top of, I'll put the formula together here, and then we can fill it in. So I have the square root of 1 minus, what's the cosine of x? So I go to my triangle, the reference triangle. Cosine is negative 4/5. Put that right here. All over 2. Now this time what would I multiply by? I've got kind of different numbers going on in here, right? But I'm going to multiply by whatever this denominator actually is over here. So I'm going to multiply by 5 over 5. And so here's what that's going to do for me. I'm going to have 5 times 1 is 5. I have a positive square root. I have a 5. I have a negative negative makes this plus. 4/5 times 5, the 5's cancel, so I have a 4. And then on the bottom, I have 2 times 5, so I get a 10. So here's my answer. I get plus the square root of 9/10. Now that's a valid answer. You could also go into that and rationalize it if you wanted to, but I'm happy with this answer right here. If you were to rationalize it, it comes out to be 3 square roots of 10 over 10. So either answer is fine. I just want to keep it simple for us. All right, then there's 2 to go. Next one is number 12 on the next page, and this one actually we have to make a new reference triangle to be able to answer this one. Here's my info. 10 to 13, use this information. I'm still in quadrant 2 actually. Make your reference triangle. They're calling it x. There it is. Cosine is negative 1/3. Well, the hypotenuse is 3. Adjacent is 1, but it has to be negative. Makes sense because it's to the left of the origin. And my job is to figure out what that missing side is. Now, this one's not going to be as pretty, right? If I do Pythagorean theorem on this, I've got 3 squared equals negative 1 squared plus y squared. It's a y value, vertical value. All right, 9 equals 1 plus y squared. If I take 1 away, I've got the square root of 8. And I said to you that we needed to tree things like that when they do break down. So if I tree this guy, he is 4 times 2, or 2 times 2 times 2. Buddies come out. This is 2. 1 buddy's left inside, square root of 2. This value is 2 square roots of 2. Now, if that's the case, now I need to put it together with my tangent half-angle formula. All right, let's figure out the quadrant, because remember it's going to be plus or minus a square root. And if I do that, if I think about what quadrant I'm in, I have again a quadrant 2 situation. Quadrant 2 is between 90 and 180. When I half it, I'm back to quadrant 1. Tangent in quadrant 1 is positive. And so I know that my square root is going to be a positive value. So I have a positive square root. And the rule says, for this guy, the rule says that you've got 1 minus the cosine is in the top of theta. I guess they're using thetas this time, right? They got me. Whatever. I'm looking back at this. This is probably a theta, right? Over 1 plus the cosine of theta. All right, so we've got a positive square root, and I'm going to take this thing and I'm going to plug in what the cosine is actually going to be. So I have a 1 minus cosine is adjacent over hypotenuse, which is kind of nice. So for this problem, I don't need to deal with that square root. So it's going to be a negative 1/3. On the bottom, it's 1 plus the cosine, which is still a negative 1/3. And so if I pull my trick of multiplying by, in this case, my denominator is a 3. So I'm going to multiply by 3 over 3. What will it look like now? I have a positive square root. 3 times 1 is 3. Negative negative is positive. 1 over 3 times 3. The 3's cancel, and I've got a 1. In the bottom, I have same thing, multiply by 3. 3 times 1 is 3. A positive negative makes this negative. The 3's cancel when I multiply, and so I get this. And so I have a positive square root of 4 over 2, and 4 divided by 2 is 2. I have a positive square root of 2. And that's your answer to 12. All right, save the best for last, because number 15 is quite the humdinger. Here it goes. Write small is all I can say on this one, right? All right, so you're verifying. In other words, there's telling you that this side really does equal this side. You just have to figure out using your identities how to prove that. And so I have one formula for the tangent of x over 2, and I'm going to go with that. And it's going to be this. We just used it a second ago. 1 minus the cosine. By the way, it's plus or minus, and it's in this kind of verifying thing, it doesn't really matter. You don't need to carry that along with it. Just keep the regular square root thing. Here it is. All right, I'm going to leave a space. You'll see why in a minute. And this, there's really not much. Remember, we don't really mess with sines and cosines. So this is the sine of x over 1 plus the cosine of x. There's a trick to these. Here's the trick. The trick is that I have no way of being able to combine these, to get rid of that square root kind of thing to make this thing work. I guess I could kind of square both sides and see where that goes. But the easier way to do this is to take and multiply by funny forms of 1. You know how we've been multiplying by like 2 over 2 or 3 over 3? They're all forms of 1. Here's what I want to do with this guy. I'm going to take, and whatever the denominator is what determines what I'm going to multiply by. This is a 1 plus the cosine. I want it to be the opposite sign. It's kind of like, remember when we did the complex conjugates, and you keep the two pieces, but you take the opposite sign in the middle? That's what I'm going to do. So because this is a plus, I'm going to multiply by this. Check it out. 1 minus the cosine of x over 1 minus the cosine of x. Now, how is that mathematically legal? And the answer is this equals 1. It looks really funny, but it's a form of 1. So that's this. And I'm going to do the same thing, same type of thing over here. I'm going to do whatever the denominator is, I'm going to multiply by the opposite sign in the middle, its conjugate. So it is going to be 1 minus the cosine of x, 1 minus the cosine of x. And so if I multiply this together, let's see what we end up with. It's going to be kind of funny how this combines together. So here it is. I have 1 minus the cosine, 1 minus the cosine. I'm still inside these square roots. They're both inside the square roots. So what I really have is 1 minus the cosine of x, but I've got 2 of them. Where in the bottom, I have a 1 plus the cosine and a 1 minus the cosine. When I FOIL them, the inners and outers cancel each other out, and I'm left with 1 minus the cosine squared x. 1 times 1, positive cosine, negative cosine, positive cosine times negative cosine is your cosine squared. So the middles cancel out, and that's where you're at. That's my new left. If I come over here, I can't do much with the numerator. I have a sine of x, I have a 1 minus a cosine of x. And then on the bottom, I've got 1 times 1 is 1. I've got a negative cosine and a positive cosine, and they cancel each other out. So I've got cosine times cosine gives me a 1 minus a cosine squared x. Okay, we're getting closer, closer. I have 1 minus cosine squared x's. See these guys right here? They're Pythagorean identities, and they equal sine squared. So that's the next thing I'm going to set up here. 1 minus the cosine of x, I've got 2 of them, over a sine squared x, still all in my square root. This guy's going to be sine of x, 1 minus cosine of x, all over sine squared x. Do you see how things are starting to shape up? On the left, if I square a square root of square root, it undoes it. They undo each other. So really what I have in my numerator is 1 minus a cosine of x. No more square because I square rooted that. The square goes away. I have sine squared x. If I square root that, I have just a sine of x. Let's see what we've got on the right. I have a sine and I have 2 of them on the bottom. So the 2 cancels with one of these, and I end up with 1 minus a cosine of x over the sine of x, and I have just verified that. So it's a weird trick to these. I think you might see one other one in the midst of your problems, but it's multiplying by a funny kind of 1 so that you can then combine it together using the conjugate rules. With opposite signs, it ends up canceling out those middle terms, so you end up with something that turns into a Pythagorean relationship in this case, and you were able to actually work your way through the problem. All right, that's our answers or for the practice problems examples for section 11.4. We have one more section, 11.5 in the unit. You can email me with any questions, and I hope you're all doing well. I'll talk to you soon. Bye.